gone through? Where's my other pages that I handed out previously?
Should it go higher?
Should it go higher?
Okay, on the stuff I handed out previously, it's all review of trigonometry. Then we had gone through constructing the graphs. I talked about the general graphs and the need to replace the letters of the alphabet. It was originally constructed as sine of theta and cosine of theta, and then I call it sine of x and cosine of x. And there's this confusion between x and y in the circle that defines the trig functions and x and y in the graph. Logging in, and where's the control? Here's the remote. I don't know if I want to have the whole screen down, but let's go. Okay, now did I do the Maple applet on shifting functions sideways and up and down?
Yeah.
I know I did that with everybody. Okay, because I know I did it with a couple people who missed last week. And as a review, we can do the same kind of thing with a trig function. And so if I have y equals sine of x, the graph looks like that. If we add something to the graph, if I do in green y equals sine of x plus, say, 1, that shifts the entire graph up by 1. So it started off with this being -1, that being 1, that being 0. The graph now goes here. Okay? Shift it up by 1. And you can also shift it left and right by replacing the x in there. So let's switch colors again. Here's purple. And so then I can have y equals sine of x minus pi over 2 plus 1. And so what will that graph as? When x is equal to pi over 2, you get the 0 of the sign that you start with. So that moves this over to here, which is, here's 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay? So that's one full cycle of the circle. And so this is a quarter of a circle, which is pi over 2. And I've shifted it over. The graph will now look like, very hard to get it right. Okay? It shifted by 1/4 of a wave to the right. Okay? The shifting applet shows you, there he is. Hello, find a seat.
Grab that chair.
Grab the chair and go sit at the end over there with Dawson. Or here. Slide over a little bit. Give him some space to rest. Okay. Good. Okay. So in addition to shifting the functions left and right and up and down, you can also scale a function. So what does that do? Suppose I have y equals x. Its graph looks like that. It's a nice straight line, 45 degrees, right? If I do y equals 3x, it still goes through the origin, but the slope is 3 now. Does that look familiar to everybody? Those who didn't do algebra, you understand that? Anybody? Okay. And what it actually, another way of thinking about that is, here's 1, here's 3. So when x is 1, y is 1 on the first graph, but it's 3 on the second graph. And what's happened is the graph is stretched this way by a factor of 3. Likewise, y equals x squared looks like this, and when x is 1, y is 1. When x is 2, y is 4, right? But if I do y equals 1/2 x squared, instead of being stretched, it is shrunk, because stretching 3 is bigger than 1, gets stretched by a factor of 3 taller. This gets it a factor of 1/2 taller. So when x is 1, we are at 1/2. When x is 2, that gives us 4. This is half as high. Here is 2. And so the graph is still a parabola, still a bowl shape, but it doesn't go up as fast. Okay? And so you can rescale a function vertically by multiplying the whole function by a constant. And so A is the letter we tend to use. And what that will do on the original function is make this become A, and stretch it so that instead of it going from -1 to 1, it goes from -A to A. And then it's shifted up, and it no longer, if I go up by A, the graph will be right. Okay? So plus A. So there it is, shifted up by an amount, a capital A. A is called the amplitude of the graph. And so each of these different aspects, and you can also scale this way and shrink things sideways. So let me see, what graph can I talk about that you will recognize as going sideways? You won't see whether or not it's vertical or horizontal. Okay, I'll bring up the applet. Web page.
Shouldn't you bring down the screen?
Bring the screen down. Yes. It's barely tall enough. Okay, now you can't get to it this way. You have to get to it through that other way that I talked about, because you can't run these. You have to get. Did I show you downstairs how to get to it through?
I didn't see.
No.
There was another.
Okay, the VOAL method from home. Remind me when we go downstairs today to show you how to get to these outputs. Get to the main.
I think you
Okay.
showed us yesterday. Or not, no, last time.
Maybe. I can't do it that way here because that's on the open access labs. This works, but you have to have a university account, which your guest accounts are not. Okay, so shifting, reflecting. I don't have one in here on scaling functions. And if somebody would like to make one on scaling functions, and we'll put it in here with shifting, reflecting, scaling is the other one. However, there's one here on the shape of a trig function. Where is it? There it is. Properties of sine and cosine curves. Should start automatically now. We will see. There it is. Okay. I don't know if you can read that or not. Do you need me to write that on the board larger?
Yeah.
Okay, I will write it on the board. It says, this is the graph of y equals a sine of 2 pi x over p minus 5 plus m. And
Is 5 like a variable?
yes, another Greek letter.
Okay.
Okay? There are 4 constants in here. X is the variable. There are 4 constants, A, P, phi, and M. And they all have a meaning. When you draw a wiggle, that has the shape of the sine curve, there are these 4 properties. If you take the average height, the midline here, where it hits the y-axis is m. So it starts at m and it goes up and down. The sine function goes up by 1 or down by 1. But you multiplied it by a. So it goes up and down by a. So this amount here will be m plus a, and this amount here will be m minus a. So this is the vertical shift. This is the vertical scaling. Okay? And this is called the amplitude. And this is more physics than math. The words are used in math too, but they come from physics. The amplitude of a sine wave is how big it is. And it is the vertical distance from the center line to either the peak or the trough. That's called a peak, that's a trough. Okay? The period is P. When x is 0, you are at sine of minus phi, whatever that is, whatever phi is, okay? When x is 2 pi, no, when x is p, rather, then this is 2 pi, p over p is 1, and what you've done is taken minus phi and added 2 pi to it. And we know that if we go around the circle, adding 2 pi doesn't do anything, right? So if we go from, say, this point here to this point here, that is 1 period. The whole thing, angle we're taking the sine of has changed by 2 pi as x moves from here to here. And so whatever number this is, x1, this becomes x1 plus p. And that's called the period of the wave, and it is the horizontal distance from one peak to one peak, or from one trough to one trough, or one midline to one midline. Okay? Those are the period of the function. So that is these 3 numbers. And what is phi? When x is 0, we're taking sine of minus phi. Phi is called the phase shift, and that's the most confusing one of these. Phase. Okay? And it tells you how much it's horizontally shifted away from the start as an angle. Okay? So if this whole thing is equal to phi, you are at sine of 0. Okay? When this is equal to phi, phi minus 5 would be 0. Sine of 0 would be 0. It's where you start your sine function. And so this place here is where I'm starting a sine curve. Sine curve starts from the midline, goes up, down, up, down. Yes?
What's amplitude?
Amplitude means the height from the middle to the top or the middle to the bottom. Okay? This whole thing is twice the amplitude. Okay? So the middle height up by A or down by A are the peak and the trough. Okay? And that distance is called the amplitude. How big of a wave it is. And this here, the x, which puts you at the starting point of a wave, this x1, 2 pi x1 over p, when it is equal to phi, we are at a place where we're on the midline, Okay? And that's at x1 equal to p divided by 2 pi times 5. And that's the horizontal shift. It's how much the function has been shifted sideways in terms of x. Over there, when we talked about it, we replaced x by x minus a number. That number was the shift. Over here, we can do the same thing by factoring this out. It is a times the sine of 2 pi over p times x minus p over 2 pi times 5. Distribute. This times x is that. This times that times 5. This and that cancel off. And we get just minus 5, which is this. Okay? I'm trying to do the algebra slowly. I'm not slow because I do it too quickly. Okay? Yes?
Did you get the phase shift?
Huh?
I didn't get the phase shift.
You didn't understand it. I know. That's why I'm trying to re-say it. Okay? The phase shift is the change in angle from where a usual sine function starts like this, starts at 0 and goes up, down, up, down. The question is, what is the angle change from 0 through to here? It is not just a change in x, it's a change in x modified by this 2 pi over p. The amount that is horizontally shifted is by p over 2 pi times 5. Because x is, in the usual sine function, x is being replaced by x minus this. That's how you get a sideways shift. You replace x by x minus a number. And that number is how much it shifted to the right. Okay? Except for the fact that it's not just x, it's 2 pi over p times x. So 2 pi over p, the x is replaced by x minus this quantity, and that quantity is the horizontal shift. But if you re-express that as an angle between 0 and 2 pi, then that angle is called phi. In other words, you take the horizontal shift and multiply it by 2 pi over p. You multiply this by 2 pi over p, you will get phi. 2 pi over p times the horizontal shift will be phi. So that's the angle that you have already moved through to where you want to start graphing. The usual graph starts at x equal to, or the angle 0, okay? And this graph doesn't start at an angle 0. The angle 0 is shifted over to some amount, and the amount by which it shifted expresses at an angle is called the phase shift. That is very confusing and not crucially important, okay? So don't worry about it too much. Yes?
So it's basically how much it has moved horizontally
From 0.
from the x value at the y-axis being 0.
Right.
How much it's moved through the ocean.
My picture is not drawn well. Let me move my vertical axis. Not at, so there, it's here. Okay, then it looks a little better. So this is going to be, this angle, or this amount here, from 0 to that. The sine function usually starts at 0, right? At height 0. That's height 0 shifted up by n. Okay? We're not starting at 0. We're off by this amount. This whole amount from here to here is 2 pi. When you think about it as an angle, 2 pi takes you one time through the sine curve. Okay? It is that fraction of 2 pi. Now, if you express it in terms of x, it's called the x shift. If you express it as an angle, it's called the phase shift. Okay? And it's that amount that it's out of sync with the usual sine function. And the physicists use the word leading and lagging. This one's technically leading. If it's behind instead of in front, then it's lagging. But the words leading and lagging are even more confusing than what phase shift is in the first place. Okay? It's the amount by which we're out of sync in going around the circle. You start here normally and come around, but if you don't start there and you start here and go around, then it's that angle that you've missed. Okay? That's called the phase shift. And if it starts out at a positive phase shift, it's called leading. If it starts out with a negative phase shift, it's called lagging. So that applet allows you to find them. I would okay, so here's a graph. And there's a graph. What is the vertical center line on that graph?
5.
5. That's the median. M is 5. And I will check it. What is the amplitude of this?
4.
See, it goes from 5 up to 9 and down to 1. So it's up and down by 4. If I did 8, it would tell me it's wrong. You entered the wrong value of A. Okay? And it shows your plot, which is way too tall. So the correct answer is a 4, and that's correct. Okay? The period. How much do we move sideways from the bottom of one of the curves to the bottom of one of the curves?
3.
3. They're all integers. Okay? So the period here happens to be 3. Check. Okay. The phase shift, oops, that should be a phi and that should be a pi. The Greek letters are not showing up in the applet. Are they on the screen any different? No. Okay, the Linux system doesn't have the fonts set right. So that should be a phi, that should be a pi. And so what multiple of pi are we off by? So there is where the usual sine function starts. At the midline, it starts going upward. Okay? And so the question is, what fraction of a full circle? So a full circle goes from there to there. What fraction of a full circle is that? Each one of the little dots is evenly spaced by an amount pi over 4. So how much off are we?
7,
2
12.
pi over 4.
We're 1 pi over 4 there, or maybe 7 pi over 4 if you go from that one. Okay? So, and I don't remember if it's a plus pi over 4 or a minus pi over 4. I'll try one and see if it's right. Pi over 4. Check. Incorrect. Oh, minus pi over 4. Check. Let's try, what did we say? 7 times pi over 4. Oh, delete the minus. Show me the answer. I didn't have to put the pi in because the pi was already out there. Okay? So, I was right the first time. I just typed it wrong. Okay? So that's why the show buttons are in there. Okay? If you do this again and practice it again, then this is a new one. What's the midpoint?
3.
3.
What is that, 3?
Nope. 2. They're integers. Okay. What's the amplitude?
3.
3. What is the period?
3.
It goes from, say, -1 up to +3.
4.
The period is 4.
4.
Okay? And the phase shift, we need to start from a place on the midline where the sine function is 0 and increasing, and we are off by -1 dot. Okay? And so this should be -1/4. And that's the phase shift. Okay? So it's 1/8 of a circle off And 1/8 of 2 pi is pi over 4. And it's lagging instead of leading. I don't care much about this one, okay? But the physicists do. So if you were taking a physics course and you were asked these questions, then you ought to get the last one right, okay? Okay, so those are properties of a trait function. That is not really on here. The next page talks about shifting and rescaling, and it does it without the, oh, it does, they're shifting. Where's the rescaling? Okay, the interior scaling, the outside scaling over here, the amplitude stretches it up or down. Inside, the multiple of x stretches it sideways. Okay? And a number bigger than 1 here will make it get bigger. A number smaller than 1 will make it get smaller. Okay? Inside, multiplying by a number bigger than 1 shrinks it. Dividing by a number bigger than 1 stretches it. Just like left-right shifts, the inside one sort of is backwards from what you intuitively think. Multiplying by a number here that's bigger than 1 makes the graph squeeze together. Multiplying in there by a number less than 1 makes it stretch apart. Okay? You got to try it and see what happens. Okay? So get out your graphing calculator or get out Maple and try comparing the plot of sine x, sine 2x, sine of 1/2 x. Plot the 3 of them. This one will be shrunk, this one will be stretched. Counterintuitive because of the size of the numbers. But that's just like sine of x and sine of x minus pi over 4 and sine of x plus pi over 4. The first or the second, which of these two shifts it to the right?
Top one.
First one.
First one, okay, because of the minus, and that's sort of counterintuitive. The same thing goes here. The one that's bigger than 1 squeezes it, the one that's less than 1 stretches it, okay? Whereas if you put the numbers outside, then they stretch the way you would expect. Okay? And this has all 4 kinds of numbers. A horizontal shift, a vertical shift, a vertical scaling, and a horizontal scaling. And so they're all 4 of those kinds of things. Shifting and rescaling. Okay, so that's, and then there's more written there about the definitions of the period and the phase, and what leading and lagging is. I'm not very concerned about them, okay? But they're there in case you want to know what the official words are. Okay. Before I forget, Luke, you came in a few minutes late. You missed 2 handouts. Did everybody else get one? Who came in right before Luke? There's a homework assignment. You don't have to do it, but if you do it, we'll go over at the beginning of next time. And then there's another handout, which is the subsequent handout. Copy. Here's a copy of it. Okay. Yes. Okay, so we're ready to start going over this one. Last time I talked about the definitions and a couple of identities, and we're moving into some other identities today. So I wanted to give you a list of all the identities. There are 2 identities missing on this list, and I'll write them on the board, and you can write them on the paper. Add them to the list. I'll tell you which they are in a few minutes. Okay, so first of all, here is a circle. Here are the axes. Here is an angle, theta. Here is the point, x, comma, y. here is the radius. Sine of theta is what over what? Not x over y, what over what? Sine is what? Y over r, right? Okay, what is the cosine? That was easy because you already had the other one eliminating the other half of it. What is the tangent?
Y over X.
Y over x, which is, if you take this one divided by this one, the r's cancel out, and you get sine theta over cosine theta, which on these new sheets are the ratio identity, the first ratio identity on the first page. Tangent is sine theta over cosine theta. Okay, then we have cotangent of theta is x over y, which is cosine theta over sine theta. It is also 1 over the tangent of theta. So that's the second one of those ratio identities on here. And it is also the third one of the reciprocal identities, saying cotangent is 1 over tangent. Then we have secant theta and cosecant theta. Secant of theta is r over x. Cosecant is r over y. So this is 1 over the cosine of theta. This is 1 over the sine of theta. And that are the first and second of the reciprocal identities. Okay? So we've now proved that much of it. Okay, quadrants. Let's take a look at the graph of sine and cosine. Sine graph looks like that. Okay? And there are 4 pieces here. First quadrant, second quadrant, third quadrant, fourth quadrant. Do you know what quadrant means?
Yes.
Who doesn't know? Speak up, you gotta tell me. You don't know. This part here is the first quadrant. This is the second quadrant, quarter of the plane. Third quarter of the plane, and fourth quarter of the plane. They're usually specified in Roman numerals. Okay? So as the angle goes around, it goes from first to second to third to fourth quadrants, each of them by pi over 2. Right? And so in the first quadrant, x and y are positive. So the sine and the cosine are positive. In the second quadrant, x is negative, so the cosine is negative, the y is positive, and so the sine is positive. And so you just do that, you go down through the table. I should draw here the corresponding graph of cosine. And there are the 4 quadrants. So the sine is positive, positive, negative, negative for the first column. The cosine is positive, negative, negative, positive for cosine. Secant and cosecant have exactly the same signs as cosine and sine. Okay? And there I'm using both meanings of the word sine. S-I-G-N. So secant has the same S-I-G-N as S-I-N. Okay? And the tangent, you simply have to do the ratios. So in the first quadrant, positive over positive is positive, positive over negative is negative, negative over negative is positive, negative over positive is negative. Okay? The secant and the tangent have the same signs. I'm sorry, cotangent and tangent have the same signs in the 4 quadrants. Any questions about that? Okay. Now I need an assistant. I'm going to just call on people from my roll sheet. Have you come up to the board and do something. Oh, we lost the screen again. We don't need the screen. Here is a triangle with sides A, B, and C. Here is a circle with a radius C and coordinates B and A. Horizontally is B, vertically is A. And A and B could be negative here, whereas here A, B, and C are all positive. Okay? And let's see, I will start with my copy. Here we go. At the top of the list, Mark, you are up. Come to the board.
Wait, what am I?
I'm going to tell you when you get there. Grab a pen. Here you go. Write down the Pythagorean theorem for that triangle. Okay, divide the whole equation through by c squared. And write it one piece at a time. Rewrite a whole new equation down below. A squared over c squared. Okay, and now write this as the square of a single thing. Quantity, something over something, all squared. Put parentheses before the square so that we know what's being squared. That's right. Next piece. What is C divided by C?
1.
And you don't need the square anymore, right? Because 1 squared is 1. Okay, what's another name for A over C? Sorry. Mark?
Sine.
Which one?
Sine.
Is A the x coordinate or A the y coordinate?
Is the
Look at your picture.
y coordinate.
So which one is
Sine.
it? Good. Write that in instead of A over C. Sine of theta. All squared.
The round angle is after the side. You put it on the side. Put it
Mhm.
Put the square thing.
That's okay. Now this is something you don't know yet. Correctly, you should be putting a parentheses to say it's the sine of theta all squared, and it's, the square can be out there,
Well, no, it's like
but people do write sine squared of theta plus cosine squared of theta equals 1. And you have just derived the Pythagorean identity for trig functions. You can go back to your seat. He proved one of the identities. Okay? Next identity or next person helping me is Audrey. Audrey's up. Okay? Yes, you did. You started with the Pythagorean theorem and derived this. Okay? You don't feel like you proved anything, right? But you did the algebraic definition, derivation,
so. Wait,
which
then
gives this equation.
so every for the Pythagorean theorem equals what?
Hmm?
So the Pythagorean theorem
With sine and cosine in there instead of x and y, or a and b, right? It's, when you look at it this way, if x is sine theta and y is cosine theta, the radius of the circle is 1, right? Okay, Audrey, here's your pen. Okay, start with this equation. Write it down again. Okay, divide both sides by cosine squared of theta. Write bigger. That's okay. Just keep going. You don't need to. That's fine. You can rewrite it, but write bigger so everybody in the room can see it. plus. You're dividing by cosine squared. Good. No, it's not 1 on the other side. That's right. Okay, now on the first term and the other side of the equation, write as the square of something. Sine theta over equals, in parenthesis, 1 over okay, what's another name for sine theta over cosine theta? Good, put that in instead. You need a different pen? Don't get it on your white pants. Hold on. What is 1 over cosine called? Okay. There is an eraser there. Your square's in the wrong place. And notationally, what's she missing?
The parentheses.
No.
The theta sign on the tangent.
The tangent is missing its theta. Thank you. And you can go back to your seat. You have just derived the second of the Pythagorean identities. Tangent squared plus 1 is secant squared. Okay? Next person is Jeremy. Come on up, Jeremy.
Come here, Jeremy. Jeremy.
And you are on that board over there. Have a pen. Right sine squared plus cosine squared equals 1. And he's a lefty. You missed your theta. I didn't say him, but you gotta have sine squared theta. Okay, your squares belong in the other place. Because that says sine of the square of theta. You want sine of theta squared. So, slow down. There's no hurry here. Divide the equation through by sine squared theta. Everybody watching?
Yeah.
Making sure he does it right? What is another name for cosine squared over sine squared?
Cotangent.
Cotangent.
Okay, next line. What is another name for 1 over sine squared? Cosecant. Theta. Except you're missing your squares. See, cosine over sine is tangent. Cosine squared over sine squared is tangent, cotangent squared, right? 1 over sine is the cosecant, and you need a square on that. You've just derived the third of the Pythagorean identities. You can head to your seat. Okay? Okay, what I said was we were going to do trig and prove all the identities, right? So we're just moving down the list. Last time I had animations that did the parity identities. So I don't want to erase the definitions. Parity identities. Okay, so sine of minus theta is equal to something in terms of sine of theta, with a plus or minus there. I know you can look at your paper.
Minus.
It's a minus because you looked at your paper.
Well,
You remember why it's true?
Because I can't.
Here's the graph. It goes up on this side and down on this side, right? So the amount, if we go over here to theta, and we go over here to minus theta, this amount and that amount are negatives. Right? Agreed? So that's the proof of this theorem. Yes?
Yeah, just on that other thing, there's just one parenthesis.
No, there isn't. Okay, we also need to know what cosine of minus theta is in terms of the cosine of theta. And I need to graph the cosine function there and there. What can you tell me about them? Plus, okay? And those are the two parity identities or negative angled identities at the bottom of the first page. Okay? Now we go on to the next page. I did complementary and supplementary last time. And over here, complementary. So here is a circle, and it's easiest to do this in the first quadrant. Here is an angle theta. Here's the angle pi minus theta. Pi over 2 minus theta. Right? And here is the coordinates x and y. So here is x, here is y, here is y, here is x. We have sine of theta is equal to something. Cosine of theta is equal to something. And my next assistant, moving down the line, is Luke. You don't need to come up. You can just tell me. What are these? What is this in terms of x and y and r?
Sine is y over r.
Y over r.
Cosine is x over r.
Okay. Then we have sine of pi over 2 minus theta and cosine of pi over 2 minus theta. So here's the angle pi over 2 minus theta. What is the sine of that? Now you remember the definition of sine in terms of opposites and adjacents. Yeah. Okay. Here's the standard triangle. Here's the angle opposite, adjacent, hypotenuse. Oops, HY. And we have sine SOHCOAH TOA. SOHCAHTOA. Okay, do you remember what that means? For the sine function, opposite over hypotenuse, right? Okay, so here, the angle is pi over 2 minus theta, which is that angle. What is the sine?
Okay, hold on. Sine.
X over Y.
Opposite, let him.
Okay, opposite. So x over y.
Hypotenuse.
Hypotenuse. That's. Oh. What's the radius?
Yep,
Okay.
R.
R. Right.
Okay, and what's the cosine of pi over 2 minus theta?
Okay. R. Sorry.
The radius is R. Cosine is adjacent over hypotenuse. What side is
Y.
adjacent?
Y over R.
Okay, so sine of pi over 2 minus theta is which one of these?
The cosine.
And
Sine.
cosine of that is sine of theta. Okay? And you have just proved the two complementary angle formulas for sine and cosine. The complementary angle formulas and the negative angle formulas for all the other functions just follow from the fact that tangent and cotangent are sine and cosine divided, and secant and cosecant are 1 over the other ones. Okay? Yes, Jeremy? Right ahead. It is, you go past the elevators and make a left. Any questions about that? Okay, last time I did it with the animations, and that is confusing on the complementary angles. The supplementary angles, the animations are reasonable. So now we come to the supplementary angles. So we now need to know sine and cosine of pi minus theta, pi minus theta. So let me draw these same two pictures now. Here we go. Two pictures. Here we have sine, and here we have cosine, and we're going from 0 to 2 pi, and here is pi. Nope, that's not pi. 2 pi, there's 2 pi. Here's 2 pi. It's one full period. One full wiggle is 2 pi. Okay? And so pi minus an angle, here is an angle theta, here is pi, so there is pi minus theta. Okay? And we're comparing the sine function here and there. What can you tell me? Are they equal or negatives? Equal. So sine of pi minus theta is sine of theta. Okay. Cosine. Here is pi, here is theta, here is pi minus theta. What can you tell me about this height and that height? They're negative. So cosine of pi minus theta is minus the cosine of theta. Okay? That's the supplementary angle formula. Okay, the next two groups, the sum of two angles formula and the difference of two angle formulas, are easy to remember. And first of all, you need to memorize it. And then we have to come to the proof. So the first thing we will do is learn how to memorize. And I will tell you how I remember it. And okay, so here we go. You write down sine, and you write down cosine. And what are the two angles called here? Alpha and beta. Okay? You could use A and B if you feel like it. Alpha plus beta, alpha plus beta. Then you're ready to write the other side. And the way to remember it is sine, cosine, cosine, sine. Cosine, cosine, sine, sine. And then you put alpha, beta, alpha, beta, alpha, beta, alpha, beta, a plus and a minus. Okay? Now, I'd like you to read these with me as I point to various words. I'm not going to do any of the alphas and betas, just the words sine and cosine. So read it with me. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. Repeat it. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. Sine, cosine, cosine, sine, cosine, cosine, sine, 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 cosine, cosine, sine, cosine, cosine, sine, sine. That's called the trig right. Okay?
Oh my God, that's amazing,
If somebody has a band and wants to record it for me, I would love to. There's a recording of my voice saying it on this whatever page this is inside your notebook. But it would be nice to have that musically recorded and put up at YouTube. Okay, that's called the trig graph. I am told there's a version of that for tangent as well. However, sine and cosine are the two that are important, and you need to learn them. Now, if you have these two, and we have to prove these two yet, but once you have those two, the next two are easy. Sine of alpha minus beta, cosine of alpha minus beta equals. Who's next on my list? Chloe. Come on up. Recopy the first line down over here. Everything on this line, but everywhere you see a beta, write a minus beta. So just duplicate that line here, put a minus beta everywhere there used to be a beta. Okay, it's all fine, except we probably need parentheses there and there to make it obvious that the minus beta is what's inside the argument of cosine. Okay, what is the cosine of minus beta? Remember the negative angle formula for it. Is it equal to cosine of beta or minus cosine of beta? Give her a chance. Huh? Which one? Okay, so recopy it on the next line. Okay? Yeah, recopy that, but replace cosine of beta with what you know about it. What is cosine of minus beta? So just write cosine beta. What do you know about the sine of minus beta? Doesn't need it because there's no minus sign. Okay? What do you know about the sine of minus beta? Throw away the minus sign, or you bring the minus sign out front? Not there. This is the one where you're doing sine. That's what we're trying to bring down here. What is sine of minus beta? Yes. Okay. Now the problem with what you wrote is you are saying, back up a little bit so everybody can see, sine of alpha times sine of beta, add to that the cosine of alpha, and subtract from that sine of beta. Is that what this said to do to these two things? What did it say to do? Multiply. So what do you have to do here to know that you're multiplying? Yes? Okay. Right?
Yes.
Or you can take the minus sign and pull it out front. Right? Put it out front. And if you put it out front, you don't need the parentheses anymore. Right? So the formula for sine of alpha minus beta, you can go back to your seat, is sine alpha cosine of beta minus cosine of alpha sine of beta. Okay? And I just copied up from what she did up there. Next one. is Hannah. Come on up.
Break into your house in the middle of the night.
Hello, Trevor. Okay, I want you to recopy this line and replace beta by minus beta.
Still repeat your computer. Digits off it.
New line.
I think we're going.
And explain to the class what you just did.
Back
Back up so they can see it. Okay. What you do? Tell them what you did.
I got rid of the,
Class, listen up.
I got rid of the negative because it doesn't matter.
In cosine.
In cosine.
Uh-huh.
And then I took the negative out. And I it out here.
Mm-hmm. And what do you do with your two minuses?
Multiply them together.
Mm-hmm. Okay, and so there we have the identity for the cosine of the difference. So, yes? Is positive cosine of beta. Same way it was here. Right? Cosine is an even function, and the minus sign goes away. Sine is an odd function, you gotta pull it outside. So if you memorize these two using the trig graph, these two are easy because all you do is replace beta by minus beta and use the parity identities. Okay? The negative angle identities.
So
Okay.
we only need the two minus.
Do you need these? No. But most books include them. Okay? And if you're going to do your high school class eventually with trig identities, you're going to see these. Okay? Now, applying these. What is the sine of 30 degrees? What is the sine of 45 degrees? What is the cosine of 30 degrees? What is the sine of cosine of 45 degrees? You should know each of these. Okay? Everyone, what's the sine of 45 degrees?
Stop.
1 square root of 2.
1 over the square root of 2. Okay, what's the cosine of 45? 1 over the square root of 2. Okay? Now, there are two numbers here, and the hard part is getting the right order. What are those two numbers?
1/2.
1/2 and square root of 3 over 2. Which one is which?
Sine is.
All right, I got to draw my triangle because I can never remember 30, 60, 90. Opposite 30 is the smallest number. Opposite the 90 is the biggest number. Opposite the 60 is the middle number. 1, 2, the square root of 3. Okay, so which of these is a half? Yeah. Yeah. Pass the elevator, make a left. Which one is a half? Cosine or sine?
Sine.
Cosine. Cosine. 30 degrees, opposite over hypotenuse is no. Cosine is adjacent over hypotenuse. Right?
Yes.
So what's the cosine?
Negative. Square root of 3 over.
And what's the sine? Okay, so now I'd like to know, what is the sine of 75 degrees? Okay, so that is sine 45 cosine 30 plus cosine 45 sine of 30, because 75 is 45 plus 30, right? And 45 plus 30, I just plug in the 45 and 30 all along it, okay? So this is 1 over square root of 2, square root of 3 over 2, plus 1 over the square root of 2, 1/2, and there is my answer for the sine of 75 degrees, okay? How would you get the sine of 15 degrees? The 45 minus 30, right? How would you get sine of 105 degrees?
Oh, use sine of 30 degrees plus sine 75 degrees.
30 and 75 makes 105, yes, that would work. Alternatively, going back here, 105 is 45 plus 60. So you could use this. So you got two ways to do it. They ought to give the same answer. Try them both, okay? And see if you get the same answer, okay? So we have proved the sum and the difference formulas given the sum formulas, but we haven't proved the sum formulas. Next time we're going to prove them from first principles, and so that we aren't just memorizing it from the trig graph, which is not a proof. That's just a mnemonic for trying to remember it. Okay? Okay, so we're moving downstairs now. Down we go. I need my board erasers.